Here come the hyperbolic derivatives. And our first question is, what is the derivative of sinh x? All right, how are we going to do this? Just like with the identities, when we prove that identity, to find this derivative, we're just going to fall back on its definition. So we defined sinh x as equal to e to the x minus e to the negative x all over 2. So if we say we want the derivative, let's just take the derivative of that version with the e. We know how to find derivatives with e. We can do this. We don't have to do anything fancy, no graphing, no tricks. Okay. When we do this derivative of e to the x minus e to the negative x over 2, you might think we need the quotient rule. Well, you could do the quotient rule if you wanted, but there's a faster way. Since the denominator is a constant, we can just move it on, and I'm going to move it out in front here of my derivative notation. Now, since it's in the denominator, of course, it needs to be a 1/2. So I'm thinking of that as a constant multiple. So I'm pulling it out, and all I got to do is take this derivative and then multiply by the 1/2. Okay, let's do it. We got it. We can do this derivative. Here we go. Let's talk about it. So, derivative e to the x, well, of course, that's just e to the x minus derivative e to the negative x. You may recognize you need a chain rule. There's the inside right there. So the derivative of e, we just copy the whole thing. And the derivative of negative x is -1. So now, cleaning this up, negative, 1/2 e to the x plus e to the negative x. Okay. All right. Now, all right, there's our derivative, but let's go a little further. This 1/2, I could put it back underneath and think of this as e to the x plus e to the negative x all over 2. And does this look familiar? Wait a second. Are you kidding me? Isn't this hyperbolic cosine? The derivative of hyperbolic sine is hyperbolic cosine. That is crazy. I mean, wouldn't we want it to be? I mean, if we've got to learn this, yeah. But then just a purely intellectual mathematical, like the derivative of sine x is cos x, and the derivative of hyperbolic sine x is hyperbolic cosine x. That is so cool. So another connection there we're seeing to the original trig functions. Okay, once we get through a couple of these, I'm just gonna list them all. So let's move on. The next question, of course, what's the derivative of hyperbolic cosine x? Obviously. This is the last one we'll do together. Then I'll list out all of them. Well, wouldn't it be cool if the derivative of hyperbolic cosine x was negative hyperbolic sine x, and it just matched up with the trig derivative perfectly? Let's see if it plays out like that. We got to do the hard work. We don't want to assume anything just because hyperbolic sine worked. Got to do each one. Okay, so again, we're just going to go back to the definition here of hyperbolic cosine. So we got d over dx cosh x equals d over dx e to the x plus e to the negative x over 2. And really it's the same procedure. We got this 2 down here. We're going to pull it out, pull out the 1/2, and just take the derivative of the e's. Okay. And okay, now taking the derivative as well, e to the x, derivative e to the x, plus this derivative, same chain rule, right? E to the negative x times -1. And if I pick it up, on the next page, my next page, well, we can just think of that as minus e to the negative x. Okay, let's put the 2 back under. Now, what did we get? Is it negative hyperbolic sine? No, it's just sine. That's hyperbolic sine x. That is crazy. Well, we almost got it. It's not the negative that we were hoping for, but hey, pretty close. And again, we kind of see this theme of, the hyperbolics compared to the original trig. Sometimes negatives and positives, get switched up. Okay, so here are all the derivatives for all 6 hyperbolic trig functions. Okay, one at a time. May need to pause to copy all these, right? Obviously. But I'm just going to keep going on. All right, so we knew that hyperbolic, the derivative of, let's just call it sinh x, is cos x. Derivative of cos x is positive sinh x. Now, what would you really hope for the derivative of tan x? Man, it would be great if it's sec squared x, right? That would match the original trig derivative exactly. And it is. So cool. Okay, then what's going on over here? Cosec x. And you would hope that it would be negative cosec x coth x, because the original trig, cosecant x, is negative cosecant x cotangent x. And it works out exactly like that. Sec x, turns out this one is negative. Now, the original trig derivative of secant x is secant x tangent x. Well, we've got that. There's just that negative issue. So the negative is here. Negative sec x tangent x. And finally, for coth x, we would really hope that it's negative cosec squared x, and it is. Okay, so looking at these, they are almost identical. I mean, 4 out of 6 are identical, and the other 2, it's just a negative sign thing here that just got reversed. Okay, so here it turns out these 3 are the positive, and these 3 are the negative. So it's not the cos that are negative, right? This negative jumped over here. It's just those are the positives, those are the negatives. That's the way it worked out. But otherwise, they're identical to the trig derivatives. So sweet. All right, so please get to know these. And, if you know the trig derivatives, which you should, these are not a big deal to add on. You just got to know that, now this is positive and this is negative, right? All right. You would think that would be the end of our section. Maybe we do a couple examples or something. I'm actually not going to do any examples with derivatives of these together because once you know the derivative rule, you can just dive right into the homework. We're still going to play with product rules here. We can still do chain rules, right? You could do the derivative of like cos 2x, right? Like what we had in the identity, right? You can mix these with any powers of x or any whatever. Okay, you get it. So I'm just going to let you guys just dive right in to the homework. We don't need to do examples together. I don't think you would really learn anything from doing those. But we're not done. Just like the original trig functions all have inverses, all of these hyperbolic functions have inverses as well, and those inverses all have derivatives. Oh no, this chill just went down your spine. 6 more derivatives. So we've got a total of 12 derivatives in this section. Okay, so let's take a look at inverse hyperbolic sine x, inverse sinh x, or you might call it arc sinh x, right? So there's its derivative. Now it's almost the same as inverse sine's derivative, but it was a minus sign before, now it became a plus. Okay, here's the derivative for inverse hyperbolic cosine, 1 over square root x squared minus 1. Now this is got some major differences between inverse cosine's derivative. So yeah, there it is. Okay, uh, inverse tangent, sorry, inverse hyperbolic tangent's derivative, almost identical to inverse tangent's derivative. Inverse tangent had a plus here. Now we have a minus. And the rest of these, okay, you know what? I'm not even going to speak to them anymore. Just copy them, right? Just we're not going to prove that any of these. We proved, I think, the derivative for inverse sine x. I just want to present these, know that they exist, know what they are. One thing it's kind of curious is the derivative for inverse hyperbolic tangent is the same as inverse hyperbolic cotangent. It's the same function. You're going to think, what's up with that? The thing is, the domain of inverse hyperbolic tangent and inverse hyperbolic cotangent, the domains of these are, what I'm trying to say, they're like, it's like reciprocals of one another, like, so if one is in one, then it's not in the other, and they like flip their domains, together make up the entire number line, if that makes sense, but there's no overlap. So it turns out that yes, their derivative functions appear the same, but you would be plugging different values of x in here because the domain of this differs completely than the domain of this. So the values of x themselves you're plugging in would be different. Okay. At the end of the day, with these inverses, now these, the original 6 hyperbolic function, know all of these. These come up, especially these here, but of course, anything can happen. When it comes to the inverses, you're going to see this stuff in homework, right? But I'm not going to put nearly the emphasis on these when it comes to quizzing and tests and that sort of thing. I'm going to put the emphasis here. But I do want you to know that these exist, these functions exist, and their derivative exists. So when you see them in the future, maybe you see them in Calc 2, or maybe you see them in, who knows what class later down the road, physics, who knows. You can say, okay, yeah, I've heard of those. I know those exist. People don't memorize these. They just look them up, right? So these, as far as testing, quizzes and tests, you're not going to see these derivatives on quizzes and tests. I'm just not going to put the focus there. I want you to know they exist. These you will see on quizzes and tests. Okay. No examples. Good luck in the homework. See you in the live meeting. That's all.